For this one, yeah, 21 here. Initial velocity is at rest. He's waiting at a stoplight. Another physics term, waiting, apparently means stopped initially. He's already cheated. He's using his graph to cheat. You cheater.
I wouldn't consider it cheating.
No, I wouldn't either. You're good. If I accuse you of cheater, I'll probably take you out the hallway before I do it. Just so we're clear. And I'm usually darn sure. No, cheating's, there's a certain kind of cheating in physics. It's very, very good. It's like, wait a second. I don't want to do this. It's no fun at all. Absolutely. The biggest problem with that approach is that what if I give you weird numbers like 17 and 19 and try to figure out 17, 19, so on like it gets icky that way. But, there's no guarantee I would do that. It actually could be pretty nice. This one's not too bad for this reason, too, going this way. So d equals 1/2 at squared plus v naught t. The distance I don't know, but 1/2 acceleration is 4. Time is 5.25 squared. Thus initial velocity of 0 times 5.25. I'm going to get the displacement pretty quickly here. It's 2 times 5.25 squared, and I get a whopping 55.125 meters. Middle stretch, the distance is 243 meters, right? So that's easy, but I need a time. How am I going to do time, Ms. Wilco? You're going to have to be a little louder. Go one time, louder. Which formula? Let's do it. Displacement formula. By the way, I'll never mark you wrong for saying that, but we got to keep that in the back of our mind. It takes care of things. What's my acceleration during this time? 0. Sweet. I don't know how much time. What's my velocity? 21 times t. So I can divide that out. Feels like that should go evenly, but apparently it doesn't. 243 divided by 21 is a whopping 11.6 seconds. So now I have time and distance for the middle stretch. All right, last stretch. Bring me home. Well, go. V equals V naught plus AT. What's the final velocity for the last stretch? 0. Initial velocity? 21. Acceleration? -5 time. You don't know that, but we can figure that out pretty quickly. 21 divided by 5 is 4.2, I believe, seconds. All right, now they have the time. What can I do? We can have the other time. I guess we can do that right now. Why not? Count our victories while we got them. One never knows when we're going to lose one. Okay, I got 21.1 seconds. Again, keeping 3 digits. This is our secret rule we do. How far did I go? I better use some displacement. 1/2 at squared plus v naught t. And this is a case where if you remember what you're doing, you could draw a triangle and be done in 2 seconds, right? You could go, wait a second, 21, 4.2, 1/2 that times that, I'm done. Or do it like you're supposed to. T equals 1/2. Acceleration is -5 times the time, which is 4.2 squared, plus initial velocity, which was 21 times 4.2. Whoa, that wasn't good. And I get the displacement for this stretch is 44.1 meters. Plus the 55.125 plus the 243. and I get 342 meters. Bien? How many? Sliding down the wall. 2. What are the 2 accelerations?
One's 2 meters per second squared, and the other one's
The other one's unknown. When he loses contact with the building, he's unknown. Negative 9.8. And I assume if we're going to make this negative 9.8 meters per second, I'm going to make this negative 2 because it's going the same way, right? So I got to keep that consistent, right? If I'm going to make that down, that has to be down too. All right, roll. All right, what do we got here? We got v equals v naught plus at. Final velocity, initial velocity 0, acceleration negative 2, but I don't have the time, can't solve that. Which forces me in the land of d equals 1/2 at squared plus v naught t. Displacement's negative 4.5 equals 1/2 negative 2 times time squared plus initial time that cancels out. A little bit of fancy math, I get 4.5 equals t squared, so t has to be 2.12 seconds. Are we in agreement? Once I have that, I can quickly solve the speed at the end of the first part of the run, which is what we needed so we could just skip the first part. Fortunately, we ended up doing the whole first part to get to skipping point. All right. That said, now it's time to get over on this side of the equation. He arrives at the bottom of this spot at negative 4.24 meters per second. Now what do we do, sir? Yeah. I got the first part done.
So then you can't do the second, you can't do the final velocity equation yet.
Right?
Because you need time.
Okay, so you're going to write the displacement. 1/2 at squared plus v naught t. We know he's going to go down 1.5 meters. 1/2, the acceleration is negative 9.8 during this stretch times the time squared. Don't know the time. Initial velocity, though, is negative 4.24, so I can get the time from this one, right? Negative 4.9 t squared plus negative 4.24 t plus 1.5. So menu, equation, polynomial, second degree, boom. Negative 4.24 and 1.5, and I get 2 answers. One's negative, that seems silly. Although, why is there a negative answer? I don't know that one. That seems real strange. Good? I got 0.274 seconds. Oh, are we in disagreement? You agree, but are you in disagreement? Don't erase your answer. Okay, so neither one, you're willing to actually throw out there the right answer, so we're going to get this whole thing wrong because you two won't let us do one share. That's fine.
So you subtract minus 1.24.
Yeah, because it's still negative.
Okay, so
It's sliding downwards.
so the speed would be negative, you can do negative speed.
Right, because it's negative velocity, but yes, going down. Right. No, I'm not arguing with him. Just technically, I can't say negative speed because then I'm, get slapped in the physics jail. Okay, final velocity I don't know. Initial velocity is negative 4.24, right? Plus negative 9.8 plus the last little stretch is 0.274. So what's his final velocity? Winter. Oh, you still got it? I just figured you were ahead of me. Whoop. 2.4 minus 9. That's not a minus. 8 minus 9.8 times 0.274, and I get a lovely negative 6.93 meters per second. Technically, I should make that positive because it says what speed. All right, I give you pain and suffering for the break. Pain and suffering, I give you all of it. Remember, Canadian Ore Company, question of week 202 is due today. Please make sure you do that. Now, this is the hard one to remember. Question week 204 we do next Friday, but that's just silly. So we'll make it due Monday, which means you should do it during the break. 204. In addition to that, I'm giving you homework. What a rude guy I am. Please, 2-9, do the whole back. I need to explain one problem, though, because you're going to struggle with it. Plant snore flat. Number 5. There's a hole in the ground. And our intrepid person, I think it's Spaceman Spiff, could be anybody. Yep, Spiff. Spiff is on a platform right here. All right? Then the thing launches him up in the air. So later, he's going to be level with the ground. The platform stops right there. And he's launched up into the air. All right? You should also know that the planet Snorflat does not necessarily have an acceleration of gravity of 9.8 meters per second squared. Well, it's a different planet. It would have a different acceleration, right? So we don't know. In fact, that's what you're going to find out. Is you're going to say, what's the acceleration of gravity on planet Snorflat? All right? Yes, sir. 202, which is something about the Canadian Ore Company, which seems like a weird, kind of weird problem that something drives you. And then 204 is going to deal with the money we get back, and that is the what goes up problem. 202 is tonight. 202 is tonight. Any other questions? Online piece, any questions?
Yeah. Did you see my email?
I did. I'm not sure why you sent it to me.
Oh. No, it was like the trick and all.
Oh, is this the answer to the magic question?
Yeah.
Oh, I haven't looked. I haven't checked to see if it's right yet. Solid.
Yeah.
All right. I will check that. It is in my box though. It's registered. There's also somebody else who sent me one similar, so I don't know which one came in first. I'm actually going to check that too. Whee!
See you.
All right. See ya. Have a nice break, sir.
Bye.
All right.
Later, Rusty.
Hi guys.
See you, Rusty.
Yeah. Yeah, I know.
Have a chance.
I've still got things to do. I'm not even going to be